scared to solve math?
Me!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is?
2 times length plus 2 times width.
Good afternoon and welcome to the elementary version of Count on Us. I'm Sherry Sternberg.
And I'm Mrs. Sun, and we are so glad that you have joined us. We are the PGCPS Tele Award-winning math homework hotline where you can give us a call and we will be able to help you with your math homework questions.
So let us give you our number. It's 301-772-0080. It's flashing on the bottom of your screen. So start calling in right now with that math homework so you can get on in the queue, we call it, get online. And while you're doing that, we're going to share some warm-ups and activities that we have, some challenges that you can be working on and thinking about while you're waiting to get to your turn. So we're going to start with the old favorite, the Challenge 24.
Love Challenge 24. The goal of Challenge 24 is to get to the number 24 using the 4 numbers on the card. You can add, subtract, multiply, or divide. You have to use each number once, but you can only use each number once. So on card A, for example, and definitely write these down, by the way. You can practice them while you're waiting. It's a fun thing to do with your family, your older brothers and sisters, so write them down. For example, card A has the numbers 1, 8, 4, and 8. So you would then use 8 twice. So you need to use each of those numbers to add, subtract, multiply, or divide to get to 24. So let's go through them and write them down. I already went through A.
Card B, write it down. Here we go. 5, 4. You thought I was going to say 3, right? Nope. 7 and 1. 5, 4, 7, 1 is card B.
Card C is 8, 6, 6, and 5. So again, you would use 6 2 different times.
And then we have card D, moving to what they call the hardest with the 3 dots, though not always the case. 3, 7, 8, and 4. 3, 7, 8, and 4. And what we'd like you to do, aside from copying them down, is work them out while you're waiting before you call in, okay? What we don't want you to do is call in and try and solve it while you're on the line with us.
Right. And definitely try to solve, remember in math there's always more than one way to solve a problem. So somebody might have a solution to one of these cards, and if you want to solve the same card, that's great, but as long as you come up with a different solution.
All right, so that's one challenge, and we always throw 2 out to you. So here's the second one. Putting my hand on my chin.
Things that make you go, For the older generation, that was a song.
We have the alphabet. Very simple, the alphabet, things that make you go, and we have the alphabet. So jot down the letters of the alphabet. We want to know which letters look the same, right side up, so in the direction they're going in right now, as they do when they are flipped vertically. So let's remember a vertical line, and if we go with a line of symmetry, it would be up and down. Okay, so a vertical line. So the suggestion would be, let's do one example and make sure we're on the same page. Write down the letter. And if you take the letter and you flip it, and you can almost see through this, I'm going to trace right over what I just did. If you flip it over the vertical line, does it look the same both ways? So we're already telling you A does. A looks the same when it's flipped over that line.
I read it if it's flipped vertically as in this, and maybe that's the wording of the question. If the letter itself is flipped vertically.
Now this would be the horizontal
line.
So
right.
Vertical line would
Shows you what I know.
All right, so so we're flipping it over the vertical line. Okay?
Sounds good.
So some letters like, and if we have some callers on the line, but after we take a couple of callers, we'll come back and look at this again with a couple more letters.
Sounds great.
So you want to take the first call?
Let's get started. Here we go. Is this Christiana on the line? Nope, or Christiana's next. Hi, Christiana. How are you today?
I'm good.
Good. And what school are you calling from?
Cherokee Lane.
Good, Cherokee Lane. In the house. Thank you for calling, sweetheart. Christiana's actually the person that made the announcement to the rest of the school about Count on Us today.
Then she definitely had to call.
Yes,
that was her
exactly.
Job to
that was her job this morning, to let everyone know about Count on Us. So what can we help you with today, Christiana?
Tell me what grade she's in so I know what we're working with.
What grade are you in, sweetie?
I'm in the 5th grade.
Fifth grade.
Cool.
Okay. All right, why don't you go ahead and let us know what you would like help with today.
I have an elapsed time question.
Okay, and what is elapsed time? Can you tell us what elapsed time is?
I know elapsed time. The elapsed means time that passed.
Okay, exactly. We want to know the difference between the start and the end time. Okay, so why don't you go ahead and give us the problem?
Okay. Katia is making brownies. They need to bake for 47 minutes. She put them in the oven at 6:30 p.m. At what time should she take them out?
Okay. And what was she baking?
Brownies.
Brownies. Yum, that's making me hungry. Okay, so what we want to do is we want to figure out if 6:30 p.m. sounds like the start time, correct?
Yes.
And we want to see what time it will be 47 minutes later. Is that right?
Yes.
Okay, so that's actually called the end time. What we're doing is we're finding the end time, okay? Let me ask you this. Is it going to be before or after 7:30? What time it finishes?
It's going to be before 7:30.
Excellent. And why do you know it's going to be before 7:30?
Because it says it says 47 minutes and not an hour. So if you went to 7:30, that would be an hour.
Exactly.
And not 57 minutes.
You got it. So we know it's less than an hour, so we know it's going to be before 7:30, and so there are a few different ways to solve this. Some people like to just go ahead and add the 47 here, but we need to be very careful. First of all, we have to be careful with AM and PM if we're crossing over the hour, so we can actually go ahead and figure it out a different way. What I like to do is start counting there, and let's count the 40 minutes on, and then let's count the 7 minutes on, and we'll break it into those pieces, okay?
Okay.
Okay. So if we're at 6:30, what's 10 more minutes?
6:40.
Okay, to 6:40. That's 10 minutes. Okay? Sorry, that's a big marker there. Starting at 6:40, what's another 10 minutes?
6:50.
Okay, and we're going to write it down. That's another 10 minutes. Okay, keep going.
Another 10 minutes would be 7 o'clock.
Exactly, because we know that 60 minutes is the same as 1 hour. So we're at 7 o'clock, and we're going to add 10 more minutes. Let's keep going.
Well, now you can't add any more 10 minutes.
Okay. Well, do we need 10 more?
No, you only need 7 more.
Well, let's count. We were adding how many minutes?
10.
We were adding 47, right?
Uh-huh.
So we so far have added 10 minutes to get to 6:40, 10 minutes to get to 6:50, and 10 minutes to get to 7, right?
Oh.
So how many minutes have we added on so far?
30.
We've added 30 minutes and we're at 7 o'clock. So we need to keep going, right? Okay, what's 10 more minutes after 7 o'clock?
7:10.
7:10 is 10 more minutes. So far we've added 10, 20, 30, 40 minutes. Now we need to add on the 7 minutes. So we're at 7:10, and what's 7 more minutes?
7:17.
You got it. 7:17 is our 7 minutes. So when we add that together, we added our 47 minutes. And we got to what time? What time does she need to take those brownies out of the oven?
7:17.
Exactly. Okay. Now, if you did add it this way, some people like to do the adding and the subtracting. Be very careful, because when we normally regroup in things, it's out of 100. But remember, when it's an hour, we're talking about 60-minute intervals. So when you're regrouping this way and adding and subtracting, be very careful of not only AM and PM, but that when you're regrouping, it's actually 60 minutes instead of 100. Okay?
All right, so we have your name written down. We're going to fold it up and put it in our treasure chest.
Can I do a challenge?
Oh, you solved one already?
Uh-huh.
Wow.
Awesome. Go, Christiana. Okay.
Here.
Would you like the challenge 24? Would you like the things that make you go,
The challenge 24.
Okay. All right. And you already solved one, you said?
Yes, card A.
Card A. All right. Go, Christiana. All right. So card A has 1, 8, 4, and 8, correct?
Yes.
Okay. When you're ready, go for it.
8 times 4 is 32.
I agree with that. Okay.
Minus 8 is 23.
Careful.
Oh.
Minus 8 is... Do you want to work on that and give us a call back? You're close.
22, 20, 21.
Why don't you go ahead and work it out? Give us a call back, sweetheart, okay?
Okay.
You're on the right track. You're on the right track. Thank you, Christiana.
All right, and we
Okay.
have a couple other people on the line. We're moving to Devin. Hi, Devin. This is Count on Us. What school do you go to?
I go to Cherokee Lane.
All
Go Cherokee Lane.
And what grade are you in?
I'm in 4th grade.
4th grade. And what are you working on in 4th grade? I think our challenge, things that make you go, is some of the things that the 4th graders are working on, because you're working on transformations. What can we help you with? Oh, you know what, Devin? Let me say to you and any caller out there, when you do make it to the phone, turn the volume down on your television, because we're echoing and I can hear myself talking. So you want to turn the volume down, watch me through the television, work with your problem, but listen to me through the telephone. So turn the volume down, okay, Devin?
Okay.
Super. Now, tell me what the problem is.
My problem actually says... Mackenzie, turned it.
Yeah, we can, exactly.
Yeah,
you can hear yourself. It's kind of scary when you hear yourself talking.
Yes.
All right, Devin, so TV's turned down. What's the problem?
My problem is that it says that what is the total faces of a rectangular prism that is the same as the cube and the sphere? I mean, no sphere. The rectangular prism and the cube.
What is the total number of surfaces in a rectangular prism and a cube?
Yes.
Okay. The number of faces that you have?
And vertices and edges, and I don't really get it that much.
Okay.
Okay.
We in our box we do have.
Do we have? I was going to use the whole box.
Oh no. Oh. Well, actually,
Either way.
I brought this in. I think we
you
have
did.
both
Look
of them
at that.
in here.
Much easier than using the whole
I
box.
thought you were going to open the box up. I thought she was helping me. It turns
Well,
out
I
no.
am. We can
Well,
use
yeah.
this box.
All right. So, what does a rectangular prism look like? Do you know, Devin?
It looks like a rectangle.
Okay, one face of it, I'm going to put this on the screen, and if you look down, you see a rectangle, exactly. But when we start talking about a rectangular prism, we start talking three-dimensional. And a cube, this is three-dimensional, and what does the face of the cube look like?
A square.
Exactly, a square. And a lot of times when teachers say, what shape is this? We'll have students say this is a square. But you have to use its three-dimensional name, and this actually looks like a dice, I was going to say, but that's plural, a die that you roll in a game, or a number generator, a number cube.
Yes.
And this is a rectangular prism, and it does have a rectangle on the top and a rectangle on the bottom. So how many sides is that, top and bottom?
2.
2. And then there's a front and a back. How many more sides is that?
2 more, so that would equal 4.
Exactly. And then there's a right and a left side. So how many is that?
6. In all
Exactly,
total.
because we have a top and a bottom, a front and a back, and a left and a right. So you just counted those, and that made 6. Well, we have the same thing on the cube, so we know that they have 6 sides. You also said you needed to know the vertices. Is that correct?
Yes.
And the
Edges.
edges.
Yay!
What is a vertice? That's an interesting word. Do you know what a vertice is?
Yes, it's what connects the edges.
Oh, you got it.
All right.
Excellent. I like the way you said that, too. It connects the edges. So let us see where those edges connect. There's some really nice computer programs where they let you color the edges as they connect, and then you know you counted them. But we're going to look at the top and make sure that we count these edges. We'll count the edges. How many edges do you have on the top?
4.
4, because edges and sides, right here, we're counting these sides. So, oh, and I'm sorry, this should have been faces. We want to say faces here, not sides. All right, so we have 4 sides on the top, okay? How many sides do we have on the bottom if we have 4 on the top? If I flip it over, how many do we have? How many sides make up that square? Devin, you still with me?
Devin, you there, sweetie?
We lost
All
Devin.
right. Well,
but
we
let's
can
continue.
finish. Yeah.
So you be Devin.
Okay, I'm going to be Devin
All right.
for a
So
bit.
we have 4 sides or edges.
Edges, yep.
4 edges on the top, and we have
4 edges on the bottom.
Okay, so 4 and 4 is 8. But now
There are
some
more.
of those were used when we counted the top and the bottom, but we have some more left that I'm not
Right.
touching yet.
We still have this 1, 2, 3, and 4 more.
4 more. So we have, if we do F for faces, E for edges, V for vertices, we had for our rectangular prism 6 faces. You just counted edges and we got 12.
12.
And the vertices are the points where they connect. So on the top we have 4, and on the bottom we have
4.
And I think we're covering all of them.
And that's it. Yep.
So there we have 8. If we look at our cube, we said we had the same number of faces. That was our cube we were looking
Right.
at. 6, 12, and 8. So our rectangular prism, well, we can see this one clearly. Our square has 4. Here's 4 sides. On that end, we have 4 more.
Yep.
And then how many didn't we count yet?
And then we didn't count these 4 more.
Because you know what? What's the relationship between the cube and the rectangular
And that's
prism?
exactly what I was going to say. If we think about it, remember that a square is a type of a rectangle with all sides the same length.
If we could slice this, and Devin's back with us, so Devin can join in now. But if we slice this into 3, we'd have 3
We'd have 3. Yeah, 3.
We'd
Yes,
have 3 cubes.
exactly.
So if we took this cube and extended it into a rectangular prism, Devin,
Yes.
I'm glad you're back. We went on without you. We carried on, but we're right here saying that a rectangular prism, RP, and a cube have the same number of faces, edges, and vertices, and we came up with 6 faces, 12 edges, and 8 vertices.
So what you're saying is a rectangular prism is just a rectangular prism.
And that is exactly what we're saying.
It's like longer.
Exactly. Which makes sense because remember, the only difference between a square and a rectangle is that a square has all sides that are the same length. A square is actually also a rectangle. So a cube is in a way also a rectangular prism. It just has all sides that are the same length. Okay? So just think about it that way.
All right? So even though we lost you, we're glad we got you back. And we hope that we answered your question, okay?
Yes.
And I hope that Miss, did you write his name?
Yes, your name, Devin, is already in the treasure
Excellent.
chest, so you can stay tuned at the end of the show to see if we pull your name out, okay?
May I do the challenge?
Now, do you have one of the solutions ready for us? These Cherokee Lane kids, they
I'm-
call in and they're always there. We love it. But make sure you have the challenge ready for us. You ready?
Did you solve it already, Devin? Are you there, sweetie?
Yes.
All right.
Did you solve one already?
No.
Oh,
Okay.
then you got to work
Okay.
on it at home and call back.
Yeah.
I did
Here are the
work
numbers.
on it. I solved one at home.
You did solve it already?
Yes.
All right,
Okay.
let me hear the numbers. Which card?
Number B.
B.
Okay, except B is a letter, but we'll go with that. 4.
4, 9, 7, and 1. Is
I don't
that
think
correct?
that's the right
Oh,
side.
I'm sorry,
Yeah, you're
sweetie.
confusing me. We
I'm
had double-
sorry.
'cause we had
I'm sorry.
doubles.
We had 2 sheets here. I'm sorry, sweetie.
All right, here we go.
1, 5, 4, and 7.
1, 5, 4, and 7. Devin, is this the one you solved?
Yes.
All right,
Okay.
let's see. Take us to 24.
7 times 4 equals 28.
All right, so you used your 7, you used your 4. Next. Got a 5 and a 1 left.
I'm minus 1
From the 28?
from the 28. Yes.
All right, so 28 minus 1 equals 27. And you have a 5 left.
And then I add that one.
Well, 27 plus 5 gives us 32, and our goal is 24. But you know what? You started it where I thought you were going somewhere else and could have gotten there.
Yeah.
So keep thinking on the track you were from here, and I think if you look at the other 2 numbers, you can get there. So go
you
back to the
think
drawing board.
So you think I should have minus 4 from the 5 from the 8, and then I should have add the 1. and then it'll equal 24.
Oh, well, then let's use that. Since we'll use that. You don't even have to. So if you take the 5 from the 28, what do you have?
You have, you got 23.
You have the 23.
Have 23, right.
And then you're going to take this 1, and what are you going to do with the 1?
You're going to add 1.
Good job, Devin.
All right, so you struggled a little bit, but then, like engineers and mathematicians, and you went back, you revised or edited or modified or fixed, and then you came up with the right answer. And that's terrific, and your name went in a second time.
Twice.
All we want to say to you and to our other callers is, do that thinking part at home and call us in when you're at the end where the 24 is ready for us, okay?
But great job. I like how you really adapted there, Devin. Excellent. And thank you for calling, Devin. We appreciate it. And we are on to our next caller. I love all the calls today. And who do we have on the line? Whoever it is, I think, needs to turn on the TV. Felicia, are you there?
Hello?
Hi, Felicia. How are you, sweetie? Can you do us a favor, Felicia? I can hear us in the background already. Can you make sure to turn down the TV and just talk to us? You can still watch us on TV, but talk to us through the phone, okay?
Okay.
And I know you're a frequent caller, so we should know that by now.
And what grade
But I
Felicia
appreciate
in?
you calling. And Felicia is in grade 4. Correct, Felicia? Is this the right Felicia? Yes. Okay. All right, what can we help you with today, Felicia?
I'm going to go with, I guess I'm going to go with multiplication.
Okay, you're calling to just throw me off, right? I'm just joking with you. Okay, do you and Devin have the same homework? You're just calling for something fun?
I'm calling for something fun.
Okay, well, we're glad you called, and we're glad to help you with anything you'd like help with. So you're going to ask a multiplication problem, is that correct?
Yes.
Okay, go for it, sweetie.
1,026.
1,026. What's the next part?
7.
I'm sorry, times 7, is that what you said?
Yes.
Okay, times 7. Okay. Well, the first thing we're going to do is take a moment to estimate. It's always important to estimate so we know about what our answer is going to be. So 1,026 is very close to another number that's nice and easy to round to and very quick to estimate. 1,026 is close to what number? We can even round to the nearest 1,000 to make it nice and quick. Is it closer to 1,000 or 2,000?
1,000.
Yeah, it's very close to 1,000 actually. It's only 26 away out of a whole 1,000. So if we multiplied 1,000 times 7, what does that equal? 1,000 times 7, or 7 groups of 1,000, is equal to what?
Equal to 7,000.
7,000, exactly. So we know that our answer should be somewhere around 7,000, and that's going to help us later to double check. So what we're going to do here, there's a short version, but what I like to do is the partial product, so we can take a look and see where our product is coming from. So we're going to multiply 7 times the 6, we're going to multiply 7 times that 20, and 7 times that 1,000, we're going to put it all together, okay?
Okay.
Okay, so instead of carrying it over here the short way, I'm going to put all the partial products down below and we'll put them together. So what is 7 times 6, Felicia?
42.
Exactly, so I'm going to actually write down right here my 42. Then what we're going to do is we're going to multiply the 7 times this 2. But instead of just a 2, it's in the tens place. So this 2 has what value?
It has a value of...
What does that 2 actually stand for?
Tens.
It's in the tens place, so what's 2 tens equal to?
It's equal to 20.
20, exactly. So this is actually saying we're multiplying 7 times 20. So we want to know what 7 times 20 is. So 7 times 2 is equal to?
Excuse me?
What is 7 times 2 equal to?
14.
Right, and then we can, that's saying 7 times 2 tens is 14 tens, and since we know it's tens, then we just transfer that 0 over. Does that make sense?
Yes.
Okay, so 7 times 20 is 140. We're going to put that down here as our partial product, okay? Then we would multiply 7 times the number in the hundreds place, which is actually a 0. So anything times 0 is Anything
times 0 is 0.
Right, anything times 0 is 0. So we don't even need to add that on. We can put a 0 here if we feel like it, but we don't need to. And then we're going to do 7 times this 1,000 over here, which is equal to what?
7.
7 what?
7,000.
Exactly, 7,000. So we're going to put all those numbers down here, and then we're going to add those partial products together. So what's 2 plus 0 plus 0?
2.
Good. 4 plus 4?
8.
8. 1 plus 0?
1.
And 7 plus itself, or nothing.
7.
Okay. All right. So our product equal, can you read that number for me, Felicia?
7,182.
Exactly, which is very close to our estimate. And that's why it's important. Sometimes if your answer came out to 700 or 70,000, you would know that somewhere our place values were off. So it's always important to estimate. Any questions, Felicia?
Can I try the challenge?
Did you already work out the challenge? You have the answer ready to go?
No, this is my first time calling,
Okay, well, we appreciate you calling. Why don't you go ahead and work out the solution first and then give us a call back, okay? Okay.
But we did write your name down. It's going into our treasure chest, so
Yes.
make sure you're watching to see if you
Yes.
win a prize at the end. But we have lots of callers on the line, and our next caller seems to be Brandon. Hi, Brandon.
Hello, can you wait 10 seconds, please?
10 seconds for you to turn the TV down?
Yes.
All right,
there we go.
8, 7, 6, 5, 4, 3, 2, 1.
Done.
Perfect.
Nice.
Timing.
Nice
Excellent.
estimation there on time.
All right, Brandon is back, and Brandon is from Brandy Wine. Is that
Good.
correct?
Yes.
Excellent. What
Great.
grade are you in, Brandon?
5th.
5th grade. And what are you working on that we can help you with?
I am working on 196 times 62.
Oh, now, I hope you just watched the last problem that was solved. Did you?
I did.
All right, so you should be able to do the exact same thing. Say your numbers again.
196
196
and 62
times 62?
times 62.
Okay, I thought you said times. Okay. And how are your basic facts, Brandon? Do you know your multiplication facts?
Well, somewhat.
Somewhat. So, and that puts a problem when you don't know them and you're working on multiplication problems. So, recommendation: 3rd graders are learning their facts. 4th graders, 5th graders, you have to have them mastered by then. And I know some of us don't in those grades. You got to work on them. So once in a while, turn the TV off and just study those facts. Okay. Now we want to do the same thing. We want to do an estimation. I call it a think bubble. We want to do a little think bubble and get an estimation so we know that we're in the ballpark when we come up with an answer, okay? So if we rounded 196, which 100 is that closest to? Is it close to what it is, the 100, or the next highest one, which is 200?
200.
So right, it's closest to 200. And how about 62? If we look at the nearest 10, is it closest to the 10 it is, 60, or is it closest to the next 10, which is 70?
60.
Yeah, 62, because we're only 2 away from the 60, and we're 8 away from the 70. So now we have 60 here, and these are what we call friendly numbers to multiply, and some people call them math tricks, okay? Because when we multiply, we're going to multiply 200 times 60, but basically we're going to multiply a basic fact, 6 times 2, and we're going to count our zeros. So what is 6 times 2?
6 times 2?
Yes, what's 6 times 2?
6 times 2 is 12.
Exactly, 12. And how many zeros do we have here?
3.
3, exactly. So 1, 2, 3. And then by those 3, we're going to put a comma here. So we're looking at an answer of about, that's the symbol for about 12,000, okay?
Okay.
So now we're going to do the same thing. We're going to get partial products by multiplying by the 2, and then we're going to get a second partial product multiplying by the 6, which is in the tens place, all right?
Okay.
So let's do these facts. 6 times 2 times 6 is?
12.
12. And as you saw last time, Miss Sun did partial products for each section, but because of our space and because you're 5th grade, you should be able to do the regrouping. We're going to take that extra 10 and bring it here. 2 times 9.
Oh, 2 times 9?
Yes.
He's thinking.
Oh, okay, 18.
18 plus 1 more that we regrouped.
10.
18 plus 1?
19.
19. We're going to bring that 9 down into the tens place and bring that 1 extra hundred up into the hundreds place. What's 2 times 1, even though it's really 100? What's 2 times 1?
2.
2 plus 1 more makes it?
3.
3. Now, this is the step students get confused about. We're now multiplying by the 6. We finished this. We're multiplying by the 6, but it's really 60, 6 tens. So you need to make sure you put your first digit in the tens place, and we remember to do that by putting a 0 as a place marker in the ones place. So what's 6 times 6?
6 times 6 is 36.
Perfect. We're going to bring down the 6 and regroup the 3. 6 times 9 is?
6 times 9 is 54.
Exactly. Perfect. And 3 more?
59.
3 more to 54.
Oh, 64. I thought you said 66. 4 more to 64. 67.
57. Okay. 6 times 9 is 54. And we're adding 3 more to that. 57.
Yeah, 57.
Right, 57. So we have the 7 here. Here's our 5. 6 times 1?
6 times 1 is 6.
Plus 5 more?
Is 11.
Is 11. Now we have the 2 partial products that we're going to add together. 2 plus 0 is?
2 plus 0 is 1.
2 plus 0. If we have 2 and we're adding nothing to it.
Oh, I thought you said 1. 2 plus 0 is 2.
Sure.
There you go.
9 plus 6 is?
Hold on.
And sometimes it's easy if you transfer one number. If we took the 6 and brought the 1 here, we'd have 10 plus 5. How much is 10 plus 5?
Oh, 10 plus 5 is 15.
Right, so it's the same thing as 9 plus 6. When we become comfortable with our numbers and move them and break them apart, it's easier to make some numbers add and multiply. So we have 15. Let's put down the 5, regroup the 1. 3 plus 7?
3 plus 7 is 10.
Plus the 1 more gives us 11. And then we have 1 plus 1?
Is 2.
And 1 more by itself gives us a 1. We're going to count 3 places and add our comma. Can you read this product for us?
Yes. 12,000.
So far, so good.
12,152.
152. Perfect. And look at our estimate. So this is a big number, and look how close we came to that estimate. So this step, and Ms. Sun recommends it as well, is very important to do that estimating first. And give yourself more credit. You did very well with your basic facts. So that was great.
Yes.
And we thank you for calling. You write his name down?
I did. Yes. Your name
Brandon
is in there.
is in the treasure chest.
Yes. And hard to believe, half the show.
Half the show.
Half the show, a little bit more than half. So, oh, Calvin, I'm sorry. Calvin, we are going to take you. You are so lucky. We're going to take you before we go to break. So, Calvin, how are you today?
Good.
Okay, and what can we do for you? What school are you calling from, by the way?
Cherokee Lane.
And what grade are you in at Cherokee Lane?
4th.
Awesome.
A lot of 4th and 5th grade callers today. That's great.
Yes, awesome job, Calvin. And what can we help you with today, Calvin?
We're doing translation and rotation and reflection.
That's what our warm-up is.
Excellent, excellent. Also known as transformations. They all fall into transformations, but I love the words that you use. I love the vocabulary. So what's the question?
Like, this kind of shape, I was like, hard to figure out, but just like this shape, they don't have
what we're here for.
Okay, so you basically want to kind of go over what those 3 terms are, translation, rotation, and reflection?
Mm-hmm.
Is that correct?
Yes.
Okay, so we're going to take out a trapezoid here. We're going to use this. So we are looking at transformations. May not have room for all that. So transformations are what we do when we're moving a shape, and they're different terms. And when you were in other grades, you might have used slide, flip, and turn. But now that we are getting older, we're using more sophisticated. I don't want to say the other ones weren't sophisticated, but we're using new vocabulary. So you mentioned can you give me the 3 words again, and we'll go over them?
Translation.
Translation.
Rotation.
Translation, hold on, you're faster than I am. Rotation and
Reflection.
reflection. Okay. So, let's take a look at this. Do any of these words here kind of stand out to you as something that you might know what to do with those? That probably wasn't the best question. Here's what I'm trying to say something, but the question didn't come out right. For example, let me take a look at a reflection. A reflection reminds me of a mirror. So if I'm looking at a mirror, I'm going to see a reflection of myself, right?
Yeah.
Okay, so that reminds me of a flip, because basically when I'm looking in the mirror, it's a flipped version of myself, correct?
Yes.
Okay, so that's what a reflection is. And you see that Miss Sternberg here underlined the FL, and that can help you. A reflection is the same thing as a flip. So anytime you see reflection, underline that FL, because it's a flip, it's a reflection of what you're seeing in the mirror. So that would be if you have a shape, okay, and you actually were able to flip it over on one side, which means that one corner or one side is going to stay in the same place. So if I took this trapezoid and I flipped it this way over the horizontal line, or I could take it and I could flip it over the vertical line. We were talking about vertical and horizontal there. As long as one corner stays in place and we are showing the reflected image or the mirror image, that's a reflection. Okay?
Okay.
Does that make sense?
Yes.
Now rotation, here I see a T right there. I see a T right here. Okay? A rotation is something, when we rotate something, we are doing what with it? We are, do you have a rotate? I'm rotating on the chair. You can't see me right now. Rotating on the chair.
You rotate a doorknob. What do you do to the doorknob? I think you might have said the word.
What is it?
I think it's turning.
Exactly, exactly. A rotation is another word for turn. When you're rotating a doorknob or something like that, you're turning it. So when you're turning a shape, one corner is going to stay in the same place, and then you're going to go ahead and turn it, and it can be sometimes a 90-degree turn or something like that. It's not always a 90-degree turn, but that might often be what you see. So you're taking one corner, it's staying in place, and then you are turning it clockwise, counterclockwise, it doesn't matter. Okay?
Okay.
So rotating means the same thing as turning. Okay?
Okay.
All right. So translation here, again, we see that SL. Okay? And when I think of translating, I think of when people translate a language. For example, if somebody speaks one language to me, my husband's Chinese. So when his parents speak Chinese, what he's going to do is he's going to say the exact same thing to me, but in English. So he's not changing the words around. He's not changing the meaning of the words. He's taking what his parents are saying in Chinese and saying the same thing to me in English. So it's really just moving something over, but not changing it. And that to me helps understand a translation, because a translation is the same thing as a slide. We're taking it from one place, we're not turning it, we're not flipping it, we're taking the same shape and we are sliding it in one direction.
Or up or down.
Or up or down, right? So left to right, up, down, diagonal, okay? But we're not turning it, we're not flipping it, we're not changing it, we're just sliding it. Just like somebody translates a language. Does that make sense?
Yes.
And then you can use that SL, that FL, and that T to help you as well. Okay?
Okay.
All right,
right.
Calvin. Well, we appreciate your call, and I hope that other listeners paid attention to that, because we seem to have a lot of fourth graders, and you're all working on transformations right now, which is the big term for all those three things. So we're going to put Kelvin's name in, and we are going to take a break. We are now past the halfway point of this show, and we're excited that we have so many callers. Stay on the line if you're on the line. Work on your homework. Work on our challenges. We'll put them up as we go to a break. There's a couple of PDAs coming up, or PSAs. PSAs. And we'll be back in a few minutes.
Hi, my name is Brandon, and I'm here with the email question of the day. The question is, Cameron received the following grades on her math test first quarter: 92, 85, 80, 85, 75, 85, and 100. The questions are, what is the mode of the data set? what is the median of the data set, and what is the range of the data set. To find the mode, the numbers have to be in order from least to greatest. The mode is the number that occurs the most. In this case, it is 85. To find the median, the numbers also have to be in order from least to greatest. And to find the median, and the median is the number in the middle. To find the median, you cross out the number in the front and then the back until you have one number left. In this case, the answer is 85. To find the range, you have to subtract the least number from the greatest number. In this case, it's 75 from 100. I know that 75 cents from $1 is 25 cents left, and so I can make the connection that that would be 25 instead of 25 cents. Okay, that's it for the email question of the day. I hope that was helpful. Goodbye.
Soccer. All across America, it's how kids get fit and have fun. Join us. Go to usyouthsoccer.org.
Version of Count on Us. You have Miss Sun, Miss Sternberg, and we've got you. And we're ready to go right to the phones because we have so many callers out there. So let's do that.
Okay.
And then we will.
That sounds good.
Share this information.
All right. So let's go ahead and see who's on the line.
Hello?
Somebody said hello.
I can't hear.
Oh, so somebody's out there. We have maybe Christiana's back. Hi, this is Count on Us. Who's on the line?
This is Christiana.
Yep, Christiana's back. So, Christiana, we're going to write your name down. What can we help you with? Oh, did you solve the challenge?
Well, I have two things. I have a fraction problem, and I wanted to do one of the challenges.
A fraction problem and one of the challenges. We like to do the problems first and then the challenges. So let's take that fraction problem first. Let's set it up here. What is it? What's the numbers in the fraction problem? What do we have to do?
Well, it's an improper fraction.
Improper, okay. That tells me, as soon as you say that, it tells me that the number on the top, which is the
numerator,
is going to be bigger than the number on the bottom, which is the
denominator.
Excellent. So go ahead. Tell me what the numbers are.
The numerator is 28.
28. And the denominator is?
7.
7. And what do you want to do? Make this into a...
You have to make it into a mixed number.
Okay, a mixed number or or a mix or a whole number, okay, because I'm seeing where this is going. Excellent, because we don't like, the word improper itself doesn't sound right, right? So if something's improper, we don't want to leave it that way. So what we need to make sure we understand is that this line right here that separates the numerator and the denominator is really a division sign. It's another way to show division. So this fraction says 28 divided by 7.
Yes.
And
we
these
learned
two
that
say
in class today.
Excellent. So these two things say the exact same thing. And this is a basic fact, Christiana. 28 divided by 7 is how much?
4.
4. So this fraction, 28 over 7, or 28 sevenths, equals 4 wholes.
Oh.
So if I took this and put it out, it equals 4 wholes, which means if I had something divided into 7 pieces, and we had 28 pieces, if we counted all of those up, we'd have 7 here, we'd have 7 here, and how much is 7 plus 7?
14.
14. We need 7 more pieces, which is? 14 plus 7?
15, 16, 17, 18, 19, 20, 21.
21. And we still need 7 more pieces. So how many would that be?
28.
28. And that would be 4 wholes. I know I didn't make these exactly even. I just did a quick sketch. But 4 wholes equals 28 sevenths. Make sense?
Yes.
Excellent. So remember that this is a division sign, and that helps you to work with improper fractions. So that was great. Did you write it
Yes,
right now?
I did.
I know you did, because she's from Cherokee Lane, so we got that.
I wrote down everyone's name is in here, I promise.
And you said you had a challenge 24 that you wanted to do?
Yes.
And you're ready with the solution?
Uh-huh. And I also had a question. Are we allowed to do both challenges or just one?
Well, we have a lot of callers on the line, so we'll do one now, and if you can call and get back in before the end of the show, we'll let you do another, okay?
Okay.
So which one would you prefer to do?
The 24.
All right, tell me the numbers.
Card A.
Card A is 8, 8, 4, and 1. Take us to 24.
Okay. Got it now. 8 times 4 equals 32.
8 times 4 equals 32. So we use this.
Minus 8 equals 24.
Yeah.
32 minus 8 equals 24. But we reached the 24, but we still have a 1 left. Now what?
Times 1 equals 20.
Oh, I thought it might trick you, but I
right.
didn't. 24 times 1, as anything times 1 is itself. So 24 times 1 is 24. We should be ringing this bell.
Good job, Christiana.
All right.
Great
Good
job. Great job.
Excellent. So your
Awesome.
name's in. Call back. See if you can get back in what we call that queue, that line, and see if you can get back on the show.
Excellent job.
A lot of
and
callers.
We do have a lot of callers. Before I forget, at the end of the show, we're going to pick a name, and you will get an order of Cinna Sticks from
yummy.
Domino's heading your way.
And if it's Christiana who gets it, you got to share fraction pieces with us with these Cinna Sticks.
with the whole school. You're gonna.
yeah.
I'm just kidding.
Not
With
even
those who
bite.
call, count on us. We'll share. Okay. So excellent. And who do we have next on the line? Is this Mackenzie?
Yes.
Hi, Mackenzie. How are you today?
Good.
Good. And it sounds like, is that the TV still in the back, or is that your sister Devin? If it's the TV, can you turn on the TV? Can you turn the TV all the way down for us,
think it's
okay?
Devin.
It might be Devin in the background.
What grade is Mackenzie in?
Mackenzie, you are in
Third grade.
third grade.
All right.
Okay. And what can we help you with today?
I want to do multiplication.
Okay, we can do that. Did you watch earlier? We did a few other multiplication problems. Did you watch that as well?
Yes.
And we
Okay.
didn't do third grade multiplication.
We didn't
That
do
was
third
pretty
grade. It
good.
was a more complicated multiplication. So what kind of multiplication can we help you with?
I'm going to do 12 times 15.
12 times 15. Okay. So that's going to be, we're going to solve it a similar way than that Ms. Sternberg solved the other one, but the numbers are a little bit smaller. Okay?
Okay.
We can still do what we've talked about earlier, and that's to estimate so that we know about what our number is going to be. So if we're looking at 12, would that, if round to 10, stay at 10, or round up to 20? Which one is it closer to?
10.
10, it is. And 15 is right halfway in between 10 and 20. So do you know which way we would round it?
No.
Okay.
I have a little
If it's-
saying.
Okay, I love your saying.
5 or more, up the score.
I like it. 5 or more, up the score. So that means if the number to the right of what we're rounding is 5 or more, we're going to round up. Okay? So we're going to round up to the number 20. Okay?
Okay.
So we're going to just estimate first to see what our answer is about. So we're going to do, were you watching before with Miss Sternberg's trick?
Not really.
Okay. Well, what we do when we're multiplying numbers with zeros at the end is it can really be as simple as multiplying first our numbers, our basic facts, and then count the zeros to add on. So what's 2 times 1?
2 times 1 equals 2.
2. And how many zeros do we have here?
2 zeros.
Good. So we're going to add 2 more zeros, and 10 times 20 equals
200.
200. So we're hoping that our answer can be somewhere around, our answer should be somewhere around 200, okay?
Okay.
Okay, now since you're in 3rd grade, I'm going to go back and do what we were doing before, which is showing the partial products down here. Later, you'll be able to do the shortcut, okay? So we're going to multiply everything. We're going to put the answers down here. We're going to add it all together. Make sense?
Yes.
Okay, so let's get started. What's 5 times 2?
5 times 2 equals 10.
Good. And I know you have been on First in Math practicing your facts, haven't you?
Yes.
Yes, I know you have. Now what we're going to do is 5 times the 1, but remember that 1's in the tens place. So it's actually 5 times 10, which is?
50.
50, exactly. So we're going to put that down here, okay? Now we did 5 times 2, 5 times 10. We're now going to multiply this number times both. This number is 1, but again, it's in the tens place. So what we're really saying here is what's 10 times 2? What's 10 times 2?
10 times 2 equals 20.
Exactly, so we're going to put that down here. And then this is in the tens place, and so is this. So this is actually saying 10 times 10. What's 10 times 10?
100.
100.
Well, you really know your facts.
I know,
Good
you're doing
job.
awesome. Their class is rocking and rolling on First in Math.
Excellent.
They're doing a great job. So we're going to go ahead and add this together, all these partial products together. So we're going to add all these zeros together becomes a?
1 0.
A 0, exactly. 1 plus 5?
1 plus 5 equals 6.
Good. Plus 2 more?
8.
Excellent. And this 1 by itself is?
0.
1 plus nothing else is?
1.
1, exactly. Okay, so here we go. All our partial products came together for the final product of 180. And when we are looking at our estimate, pretty close, isn't it?
Yes.
Okay, so excellent. We did partial products. We put it together. There we go. And you did a great job. That was a hard problem for third grade multiplication right now.
excellent.
Can I do a challenge?
We have a lot of callers on the line, so we're going to get to our callers,
Okay.
and we're going to hold off on challenges right now, okay?
Okay.
So, Mackenzie, we did write your name down, and we got it going inside, so keep watching for those Cinesticks. But we're going to go right to our next caller, who's Alicia. Hi, Alicia.
Hello.
All right, now you need to turn your TV down because I heard me saying hi, Alicia, twice. Guys, that you're on the line, I know you want to hear for your turn, but as soon as you get your turn, turn that down. All right, Alicia, how can we help you? We are running out of time. You are from Bond Mill? Alicia, you're from Bond Mill?
Yes.
And what grade?
2nd.
2nd grade. All right,
Okay.
and you're doing multiplication? Tell us what problem we can help you with.
Sure, wait. I have a homework.
Okay, I'm still hearing that echo, though. That TV
And it
has to be
says-
turned down, okay?
Okay.
All right, so tell me the homework problem.
It says to find out, look at each problem below.
All right, remember, I'm not seeing the problem, so just read me the problem.
If the product is correct, color the space green. If the product is incorrect, color the space yellow.
Okay, so they gave you some products. They gave you some multiplication problems, and if they're correct, they want you to color it green, and if it's incorrect, they want you to color it yellow.
Okay,
so tell
product.
us a couple of those, and we'll see if we can help you. Tell me what one of the problems is.
7 times 3.
7 times 3, and what number do they give you? Do they give you a product with it?
Yeah, 10.
10. Okay, see, they're trying to trick you here, because if we add 7 plus 3, we get 10. But when we multiply, we're going to take 7 3 times. And we're going to get 7 plus 7 plus 7, and we're going to get 21. So does 21 equal 10? Is that the same?
No.
No, so this one would be incorrect. So it says if the product is correct, color it green. Is that what it says, Alicia?
Yes, it says color it green if it's correct.
All right, well, don't color that one green. That one's not correct. Okay? Give me one more, and then that's how you do the rest of them. Give me one more.
Okay, sure. 10 times 3.
10 times 3. And what number do they give you there for the product?
43.
43? They're trying to trick you. 3 groups of 10. 10, 10, and 10. How much is 10 plus 10 plus 10?
30.
30. Does 43 equal 30?
43.
Is 43? No, don't color that one green. So do each one that way, okay? If it solve the problem yourself without looking at their answer, and then see if your answer matches theirs. If it does, make it green. If it doesn't, make it yellow, okay?
Okay.
Excellent job, Alicia. Your name is written down?
It is. It's in the treasure chest,
All right,
okay?
let's get a couple
so
more
stay
calls
tuned.
before we run out of
Let's see
time.
how much we can fit in. Amy, how are you?
Good.
Good. You're in 4th grade from Cherokee Lane?
Yes.
Awesome. Okay. Welcome. We're going to try to get through as many calls as we can in 4 minutes. So what can I help you with, sweetie?
Division.
Okay. What's the division problem?
9 divided by 520.
Okay. So what you probably mean is 520 divided by 9. Is that correct?
Yes.
Okay, so we want to see how many times 9 goes into 520, okay? So I'm going to go through this really quickly. We want to see if 9 can go into 5, but it can't because 5 is smaller. So we're going to see how many times 9
put it on the camera so
goes
she can
into
see.
52, okay? 9 times what gets us as close to 52 without going over? Can you tell us that?
9 times 1.
9 times 4. Do you know 9 times 4? 36. 9 times 5. 45. Okay.
45.
9 times 6 is 54. That goes a little bit too high. So it goes in 5 times. 9 times 5 is 45. Okay. And I'm going a little fast. We're going to see how many people we can fit in. So we want to find the difference here. Okay. So the difference between that is 7. 7's less than 9, so we know that 5 was correct, okay? So we're going to bring down the 0. Again, how many times can 9 go into 70 without going over?
9 times 7.
Here we go. We're going to practice our 9 facts, okay?
Okay.
Okay. 9 times 7 equals 63, okay? I'm going to show you a trick tomorrow. Make sure to come to me tomorrow. I'll show you a trick with the 9s tables, okay? We're going to subtract that again, and the difference is going to be 7, okay? 7's less than 9, so we know that 7 was correct. And because you're in 4th grade, right?
Yes.
Okay. Because we're in 4th grade, we're going to just put that remainder of 7, okay?
All right, so we
Okay.
have Amy's name going in. Amy, you're the last name, so keep watching. We're going to jiggle these up,
Okay.
shake them up, close the box, shake it up real quick.
Okay,
We
I'm
only
gonna
have
shake
another
it.
minute.
So
while she's shaking it up, let me tell you that the middle school and pre-algebra version of Count on Us is not going to be coming on next because we are going to go to the board meeting and watch the swearing in of the new board members. So make sure you tell your parents to tune in for that because that will be so exciting.
So it will. Erica and Linda, thank you for calling. Come to me tomorrow at school with your question if you still have a question, but we really appreciate it. Sorry we couldn't get to your
thank
call.
all our callers, not just
all of our
Erica and
calls.
Linda. But,
yes,
oh,
it's just
they're
Erica
waiting
and
on the
Linda we
line.
never
Gotcha.
got to. We never
All right.
got to them.
Today's winner is Christiana.
All right.
She had her name in several times.
She called twice and she solved the challenge. So great job,
Probability
Christiana.
was there.
All right.
So she's getting some Cinnabons that she'll be sharing with Miss
With
Sun
me,
and I.
yes, all of us.
And for Miss Sun and I, please remember that you can always
Count on us. Have a great afternoon, everybody.